All right, class. Today we're going to spend some time doing some mixed practice problems on our different laws of exponents. And this is 4.5 in your workbooks. This is on page 195. And again, I just want to quickly review that we have the 5 laws that we've gone over. We've done the product rule. When we multiply, we add our exponents. We've done the power rule. That's when we have our parentheses. We multiply our exponents. We have the quotient rule, which is when we are dividing our different exponential expressions and we are subtracting the exponents. Then we had the negative exponent, and that's when we're actually going to flip the expression, that either having 1 divided by that expression or vice versa. And then the last one is the zero rule, which means that any value to the 0 power is 1. So anything to the 0 power is 1. So let's take a look at a couple of examples here. Again, page 195 in your book. This is 4.5. Let's take a look at number 4. Okay, so right here, I'm looking at my power rule because I see the parentheses. Negative 4y squared to the 3rd power. I believe this is the first time that we've seen a negative coefficient. Really doesn't matter because we're just applying the 3 to that negative 4. So it is negative 4 to the 3rd, and then y 2 times 3, y to the 6th. And then we're going to have to go ahead and multiply that out. 4 times 4 is 16 times 4, oh my gosh, is 64. And that's going to be negative because it's an odd, it's a negative times a negative is a positive times a negative is a positive. So negative 64 y to the 6th. Power rule. Okay, let's take a look at number 6 here. And this right here is a power rule as well because we have the parentheses. Okay. The key feature here is that if any expression is outside of the parentheses, that power does not apply to it. So in this case, the power of 2 does not touch that x squared. So we're going to do x squared, and then that's times, parentheses multiplication, x to the 3rd to the 2nd power. So we're going to use multiplication, so that's going to be x to the 6th, and then y squared. Now I use my power rule, but now I have to go back to rule number 1, the product rule, because I'm multiplying exponential expressions here, and that now we're just going to add those. So x squared times x to the 6th is going to give me x to the 8th power times y squared. Let's take a look at number 10 here. This expression is 5a squared, b to the 4th. That whole thing is raised to the 3rd power. And actually, let me put this over here too, that this was power plus product. I think that just makes it in the board there, power plus product. This is power here, 5 times 5 times 5. So that's 25 times 5 is 125. A to the squared, but that's 3 times. So 2 times 3 is a to the 6th. B to the 4th, 3 times is going to give us b to the 12th. Let's go ahead and circle that solution there. And then let's go over to number 12. Okay, here we're going to do the product rule first. And then we're going to do the power rule because we see the parentheses there. Okay, so kind of like order of operations, I'm going to do what's inside the parentheses first. There's a little variability there. Sometimes you can get away with doing both. But let's go ahead and combine using the product rule right here. 3x squared times 2x squared is going to give me 6x to the 4th. Product rule, I'm adding. Product rule, I'm adding. Now I'm going to raise this whole thing to the power of 2. So now I have my power rule, and that's going to be 6 squared is 36. X to the 4th, I'm multiplying my exponents with the x to the 8th power. All right, let's keep motoring here. We're still on page 195. Number 16, x to the negative 5th. So this is going to be one of our negative exponent rules. And the rule that we just did in lesson 4.3 we had a little summary down at the bottom there, is that we are taking the reciprocal of that expression. So in this case right here, that in order to make this a positive exponent, we are going to write it in reciprocal form. So x to the negative fifth is the same as 1 divided by x to the fifth. Let's take a look at this one. Very important here. This is also a negative exponent rule. The negative 3, 6y to the negative third, only applies to the y. It does not apply to the 6. There's no parentheses. There's nothing touching it. So we are going to write 6, and then I'm going to write 1 over y to the negative third. Excuse me, it's positive third now. And if we multiply this across, we are going to get 6 over y to the third. So again, that negative 3 does not, as an exponent, does not affect the coefficient 6 at all. Number 20, we're going to motor in here. I see parentheses, so I know it's a power, but I also see a negative 4, so I also know that it's a negative exponent rule. In this case, when I see something in parentheses, typically what I'm going to do is I'm just going to flip it. I'm going to take the reciprocal. So if this is 3b, any expression can be written as over 1, 3b over 1. I'm going to make it a reciprocal, and I'm going to go 1 over 3b. That makes my exponent positive. Okay, now I can continue by applying this exponent to my 3 and my b, and that's going to be equal to 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the fourth is 81, and then b to the fourth. Again, anytime you see that negative exponent, we're just going to go ahead and flip it. Get the reciprocal. Last one here, x to the negative fourth, y to the third. Now you'll notice here the negative exponent is only applying to the x there and not the y. And so all I'm going to do is I'm going to put y to the third, no change. But because x has a negative exponent, we're going to put it in the basement because we find that negative exponents are always positive when you throw them down in the basement there. So we get y to the third divided by x to the fourth.